Hello and welcome back to the Networking Fundamentals section of this course. In this video, we'll be discussing class of service. Class of service is layer 2 traffic differentiation. Where you would need this is during times of congestion, and it is because not all traffic is equal. Some traffic streams are more critical to a business than others. Take, for example, database transactions and your front desk person surfing Facebook. Which one of these two traffic streams would you rather actually be successful in making it to its destination in the event of network congestion? Something tells me you probably care more about the database transactions than allowing your front desk person to surf Facebook, or perhaps the slacking security guard working at the branch office. That during times of network congestion, we need to prioritize our traffic. If it is not prioritized in some way, it will be dropped in an unpredictable fashion. See what happens, and here's an illustration to show when a packet arrives at our device and is to be forwarded. It arrives and is stored in a very small buffer first, a buffer for that interface. And these packets are queued and will be released into either the system on receive or be transmitted out onto the line on transmit as able. However, once that buffer is full, if a packet arrives and it is in no way prioritized, it will simply be dropped. And once this buffer becomes available again, then the packet will successfully be stored in the buffer to be transmitted or received as appropriate. Now, if we have prioritization of our traffic, we can have several different queues, maybe a nice big queue for our video data or database data, and a small queue for our Facebook traffic. And that way, when our Facebook traffic comes in and it goes over here, once that queue is full, that traffic will be dropped if that queue is full when that packet is received. But our voice or video data should have a much larger queue. Additionally, we could also do dropping of the packets within our queue if the traffic is classified at a lower classification. So how exactly do we classify this traffic? Well, we do this with class of service. At layer 2, at least, there are multiple ways to classify your traffic and mark it within the actual header of that packet. However, class of service, or COS, specifically refers to the layer 2 classification and differentiation of traffic. The class of service header is in the 802.1q header, our VLAN tag header, or the 802.1p. It is a 3-bit field here in our user priority section of our 802.1q header. This allows for a decimal representation of 0 to 7, 8 possible values. And it classifies traffic to differentiate the importance. So, what do these different values mean? Well, the priority values can be mapped really in any way we want. On the configuration of our device, we can map any of these 8 values to do anything that we want, or to apply a certain queue, apply a certain low latency, a certain importance. However, the standard classification suggestion here is that the lower numbers, starting with 0, are the less important traffic, and the higher number, up to 7, is the most important traffic. That down here we have network control, Our control messages for our routing protocols need to be very important to make sure that our traffic can actually be routed appropriately. But then below that, we have our voice and video, which is more important, it lists, than critical applications. Typically, applications will have some reliable transmission mechanisms built into them to where if the traffic is dropped, it's okay, it will be retransmitted through the specifications of the application. However, voice and video are real-time applications. If our voice traffic is dropped, it doesn't make any sense to retransmit it a second or two later because we're now a couple words further down in our conversation, and suddenly we have different words showing up and we're hearing the other person talking out of turn. That just doesn't make any sense. So when that is dropped, it should just be dropped and not retransmitted. So it is very important because it is what's called a real-time or RT protocol, a real-time protocol. So moving up the line here, we have excellent effort and best effort, and then background. Background meaning if there is any congestion, background will be the first one to be dropped. And then best effort, and then excellent effort, and so on and so forth. So that's class of service. It is our layer 2 traffic classification. You may have heard of quality of service, or QoS, and might be wondering what the difference is. Well, quality of service is the layer 3 differentiated services field, our DSCP, the differentiated services code point. This is a 6-bit field, and it's located up in layer 3 in our IP header. Whereas the class of service does not have as granular control. It's only a 3-bit field, and it's down in our layer 2 in the 802.1q or P header that we see here. It's within our 802.1q tag that we have our 3 bits for user priority or our class of service classification. Now, while DSCP provides more granular classification, it is not mentioned in the exam topics at all. I just wanted to compare and contrast these briefly so that you could know that there is a difference between COS and QoS. That COS is our layer 2 diff-serv field, although you shouldn't call it that. It's the layer 2 classification field that is 3 bits, and our quality of service, the diff-serv or DSCP code point, is 6 bits. Excellent. I really appreciate you going through that with me. I hope that this has been informative for you, and I would like to thank you for viewing.